Hello everyone, welcome back to the new video. In this, we will be discussing about distance from source to destination, Bellman-ford algorithm. In the previous video, we have discussed about the Dijkstra's algorithm that is used to find the shortest distance from source to a destination when the graph should not contain any negative edge. Okay, but if we are getting even one of the edge is a negative, so that cannot be determined by a Dijkstra's algorithm. Then we have to move to a new approach, that is Bellman-ford algorithm. Now even Bellman-ford is not like will satisfy all the conditions. It has some limitations. Okay, now the Bellman-ford algorithm, it can calculate this from distance from the source to destination, that is the shortest distance, if there is a negative edge. Like you can see in this graph contains a negative edge. So by seeing this, we can see that yeah, it cannot be solved by a Dijkstra's algorithm. We should move to some other algorithm. Okay, but in Bellman-ford algorithm also we have to see like if a graph is cyclic or acyclic, because Bellman-ford algorithm only works for a directed acyclic graph. Okay, that means cycle should not be there. Okay, so here we can see this from coming to 2, then to 0, and then for okay, this is not a cyclic. Okay, I would say this is not a cyclic, but yeah, this is not a cyclic, just different edges contained, but some kind of cyclic part should not be there, because cyclic thing is like Bellman-ford cannot handle. Okay, now this two conditions should satisfy, then only this Bellman-ford we can use. Okay, and if we are getting some problem, like we have to find like if a graph contains a negative edge or not, then we can use a Bellman-ford algorithm. Okay, in my previous video we have explained about the negative edge cycle. So you can check out that video. Even that is a version of Bellman-ford algorithm itself. Okay, not a version, it's the same thing. Okay, just a little bit modification is there. Okay, now we should start off with the problem. So first, in the input part, what the things will be given to us, like number of vertex will be given. Okay, now number of vertex will be given. Now array list will be given. Okay, now array list of array list, this will be the adjacency list. Okay, this will be the adjacency list, like from source to destination, what is the weight, okay, of the edge. And then from the source, vertex will also be given, like from which source to for all other vertex we have to find the shortest distance. Okay, now for this we should first create a single dimensional array that we have to return ultimately at the end. Okay, so we will give the name as a distance, since we have to find the minimum distance from source to destination, and it will size will be equal to b. And initially we will put this all as infinity, because we have to find the minimum distance. So at a maximum something we have to keep all the edges initially. Okay, now arrays will use an inbuilt function to fill this, arrays dot fill. Okay, arrays dot fill, and this will be the distance. This will be the distance, and we can't put infinity over here. In Java we will use an integer dot max value. Okay, max value, sorry, this should be max value. Okay, now and for the source, that will be source, it should not be infinity, it should be 0. Okay, and distance of s will be 0. Okay, now again what we are going to do is, like for each and every edge we will check for n minus 1's time. Like here the edges is 2. Okay, so we'll check one time, but when the edge will be 3, 4, then we will check for each and every edge. The condition will be checked at some number vertex minus 1 times. Okay, so for int I is equal to 0, I should be less than n minus 1, and I should be plus plus. Okay, this is just to keep a check that my for every edge my condition is running n 1 times, okay. And then I'll be running another that will be for each of my edges, okay. That will give each of my edges, and that I'll take in array list of integers, array list of integer list, okay, in adj. So at the first it will give me this inner one, okay. From here I'll extract this first one will be the source, second will be the destination, and third will be the weight, okay. Like here you can see source, destination is 1, and the weight that will be given is a 9, and it will be a directed, okay. Now directed part it will be there. So first we have to take out like a source will be adj dot 0, okay. Okay, and then the destination will be there, adj dot get 1, okay. And then the weight will be there, that will be adj dot get 2, okay. Now after finding this, we will check for a condition, okay. We'll check for the condition, okay. That condition will be for filling up this distance area, okay. Okay, now first I'll go, and the first thing, one more condition, like for the the node that we'll be checking will be either the first node or a node that has already been previously visited, okay. So distance will be of source, okay. Source that we are visiting should not be equal to the first time, that is not max value, okay. Max value, this should not be there, okay. And means this should be either the first node, because first node we have kept the value of 0, okay. So first it should run for it, then the next time it should be running for the node that has already been visited, okay. Like for this value we have initially given infinity, but after visiting it will be changed, so again it can run for this node, okay. But initially when it's integer or max value, it can't take that value, okay. Now the second thing condition is like distance of destination, okay. If it's greater, like distance whatever is the destination thing, like infinity is there, it's greater, okay, greater than the source vertex, that is 0. Distance of source, okay. Distance of source initially it will be 0, and the weight will be 9. So 0 plus 9, it's less than the distance of this destination, that will be infinity. So if this condition arises, then we will just swap the values, okay. Not swap, they will just store the value, okay. In the destination part we'll replace the value with the smallest value, okay. Now for this, yeah, this will be done for just one times, okay. One times it will be performed, and then again it will go, since no other adjacency list is no other array list is present, okay. So it will terminate it, and again it will go over here, and since you can see only two vertices there, so 2 minus 1 will already be 1, and 0, so 2 less than 1, so it will just run 1 times, and whatever will be stored in the destination array will be returned at the end, okay. Will be returned at the end. So now since it's a Bellman-ford algorithm, now you will be wondering that if it's like containing a negative edge cycle, so it will not be containing, since because in the condition only we have been given, like we will be given a word, a graph that does not contain any negative cycle. It's given in the condition, so we don't have to check for it. But if it says that it may contain a negative edge cycle, so in that case you can just repeat this loop, okay. repeat this loop one more times, and you can see if any of the vertex this condition satisfies and my control reaches to this condition, that means a negative cycle, that is the negative weight cycle is present, and here we will return some specified value whatever will be the given in the question, and hence the all of the condition of the Bellman-ford we have to check it. Then if this note and all some kind of hint is not given to us, then we have to check it for everything. Okay, now in my channel you can see a program of negative weight cycle. From there you can get an idea of how we will be implementing this further for checking the negative weight cycle. Okay, so this was okay, I have not run it. Okay, I'll run and check. Okay, now it's showing some kind of error. Okay, n minus, okay, we have taken v, not n. Okay, this number of vertex. Okay, this is v. This is v, not n. This was minor error. Okay, then adj dot get 0. Okay, this should not be adj, this will be list, because adj is like whole of the thing. This whole thing we are considering as adj, but this only this the interior part we are considering as a list, so it will be the list. Okay, and the list here also it will be the list. Okay, spelling. Okay, now for all the test cases should pass for it to be 100% correct. Okay, it's not passing. Now what's the error? We should check it, like what's the error is occurring. Initially we have stored the distance with a 0. Okay, n minus 1 times and a dot list. Okay, this is okay. Yeah, one mistake we have done, it's like it will not support this integer dot max value. We have to take it something like 10 to the power 8. Okay, 3 4 5 6 7 8. Okay, it will not support this kind of thing. Okay, now here you can see it will run. Now it has run successfully. Okay, now it has run successfully. Okay, so this was about the distance from the source Bellman-ford algorithm. Thank you.